This is Mr. Beck Does Your Homework. This is physics homework number 23, question number 2. Find the equivalent resistance of the circuit in the figure. Well, I've got some weird things going on here. I've got a 5.5, a 7.5, a 15, a 19, and an 11. Now, some people want to look at these two and think they're parallel because they're shown parallel to one another. Some people want to take these two and think they're series because they're shown series to each other. But remember, the rules is when you're replacing, you have to be able to draw a circle around any pair of resistors, but inside the circle it has to be entirely parallel or entirely series. And that line can only cross two lines so that you have some place to put your equivalent resistor. So if you try to grab, say, all three of these, well, I could do that with crossing two lines. But inside, these two are series, but this one is parallel to that combination. So if you think of the current that's leaving the battery, it goes through this one resistor. Then it has a choice. It can split, go that branch and that branch. If it goes this branch, it'll go through both of these before coming back together. And then if it goes this branch, it's going to come here and come back together. So the current's going to combine again, and then all the current's going to flow through this one. So what I'm going to do is I'm going to take these two resistors because they are series one with the other, and I'm going to combine those two. So I've got a 5.5 and a 7.5 in series. That means they simply add. So I'm going to have a single resistor here that's going to be 5.5 and 7.5. So that's going to be my R1 plus my R2 is going to be 5.5 and 7.5. Now I still have this 15 ohm resistor here, and I still have an 11 ohm resistor here. So this one's 15, this one's 11. I still have my battery here, and I still have a 19 ohm resistor here. So now I've got this combination, I've got this one, and this one. Well, these two are going to be in parallel, so I can redraw this one more time. And now I'm going to have a 19 here. I'm going to have a single resistor replacing these two. And then I'm going to have another resistor down here, which is my 11. And then I've got my battery. So I'm redrawing the circuit. So this one is going to be the combination of these. Well, I've got 5.5 and 7.5. So that's 6 and 7. That's 13. And this is 15. So this resistor, 1 over the total there, it's going to be 1 over, my combination here is 13 plus 1 over 15. So it'd be 1/13 plus 1/15, and then I'd inverse that to get my total resistance there. This one is still 19, and this one is still 11. Well, I've got one more combination I can do, and this one, and this one are now all in series. So I'm going to add them all up, straight add them all up, and I will get a circuit with a single resistor, and that resistor will be the sum, 19 plus 11 plus whatever this total resistance was when I did that. And that will give me my equivalent resistance of that circuit. So here I'm just going to have 19 plus 11 plus whatever this one was.